everyone to join the workshop on IoT, IIoT and Industry 4. So today we are actually doing highlights for all the emerging technologies for this IoT, which is previously come as a buzzword, but now it goes for the reality term, and the business model and other things are coming with IoT and Industry 4. So all the companies are moving, so we will check to this agenda. So basically I have more than 18 years experience in information technology and telecommunication space. So currently I'm working in solution architect at Ericsson, and the areas of my interest is currently the emerging technologies, IoT, Industry 4, smart solution and data science, which will actually dominate for the next at least 10 years. So my key projects up to now. So I am currently working in big data transformation project in Grameenphone, and also the Grameenphone software upgrade project, tech refresh project, and business builder of IoT of Ericsson. And also Bangladesh Iron Swap program, I work as a lead. So I have many certifications up to my whole career. So this is listed here. And recently I have an opportunity for the last 2 months to visit BPO Summit, which is Bangladesh government's one of the top agenda. So I joined that summit. So the government is focusing on all the emerging technologies like IoT, blockchain, so machine learning, artificial intelligence. So these are the focus point for the government. So I have opportunity to join on that day. So this is my certifications for the career from 2001 to till this year. So let's start. So what is the term basically IoT or Internet of Things? So if we see the definition, that the IoT is the network of physical objects access to the internet. So basic thing.
I have a question.
Yes.
Master take up like the internet presentation to
Okay, please go. Okay. So basically, so it is connected with internet. So we know that internet is penetrating the world. So this is the definition. And what is the industrial Internet of Things? That means IoT. That means in simplistic term, it connects the world of industrial things with sensors, actuators, and controllers. So let's go with the first video to understand what is IoT.
For tomorrow, no decision will be taken lightly anymore. Companies will increase their efficiency exponentially, or towns will be smart cities connected through the Internet of Things. Take waste management, for instance. Thanks to a wireless sensor, you'll be able to know in real time the exact level of waste in a container. You think that's expensive? Think again. You think the ecological footprint is too big? Quite the opposite. The Proximus IoT platform gives you access to the LoRa network, which consumes far less energy than the 4G network, for example. Furthermore, the sensor's battery will last for 5 to 10 years. Imagine you can check the level of waste in all the city's containers in the blink of an eye. By sending out collection vehicles only where it's absolutely necessary, you can optimize waste management. This will increase efficiency and reduce your fuel and energy costs. Fewer waste trucks will drive through the streets, and your city's trash cans will always be emptied at the proper time. This is just one of the possibilities on how IoT can improve current waste management solutions. What if we could keep track of wasted food in supermarkets and restaurants, when to pick up containers for recycling stores, or get a notification on your gas tank at home is almost empty? The possibilities are infinite. Thanks to its IoT division, Proximus is on the verge of an unparalleled revolution in the history of mankind. Pass the word. With Proximus IoT, the world of the future is starting today.
So we just get information that how IoT helps one of the use case like waste management, how it is helping. So if you go to the
Second video.
this one, so that we can get basically what is IoT terms.
Internet of Things has the potential to increase global productivity up to 25% by 2025, which could translate to an economic value of $11 trillion. Industries like manufacturing are embracing the potential of the Internet of Things. Many production facilities are already using processes and supervisory control systems with connectivity. The Internet of Things for manufacturing is a family of solutions that combines the capabilities of analytics, cognitive computing, and the Watson Internet of Things platform to drive operational efficiency across the factory value chain. This solution benefits the manufacturing industry in three main ways. First, it helps plants get 100% efficiency out of their equipment by identifying and solving issues before they cause delays. Second, it makes processes and operations cognitive, so plants can produce maximum quality and yield from raw materials and manufactured components. Lastly, it helps plant managers better manage resources, improve worker expertise, and provide a safe working environment. Advances in these three areas define a new wave of connected manufacturing, one that revolves around things, process, and people. Let's take a look at how this works for Simon, the plant manager for an aircraft manufacturer. Simon oversees the production of key components for large commercial aircraft, and his top priorities are meeting production deadlines and producing airplane parts safely and efficiently. One of his biggest clients needs to move up their delivery date by 3 months. Simon and his team use the Internet of Things for manufacturing, which will help them deliver earlier than originally planned. An equipment analytics solution identifies problems with equipment health and performance before they happen and prescribes maintenance procedures so Simon's team can avoid equipment failure and downtime, getting maximum effectiveness out of their equipment. To ensure the components are meeting quality standards along the production line, Simon uses a quality analytics tool to identify variability in the manufacturing process in real time. This allows equipment operators to make adjustments to process parameters based on plant conditions that could affect the quality of production. By monitoring quality in real time, Simon's team can avoid producing faulty components, ultimately saving time and money. Another priority Simon has to account for under a rush schedule is the safety of his plant workers. The Cognitive IoT platform includes worker safety technology that monitors things like exposure to extreme heat or toxic gas, open flames, and operating dangerous machinery. The plant workers wear sensors in their helmets and wristbands that provide real-time alerts on working conditions, activating preventative measures if physical well-being is compromised or safety procedures have not been applied. Because the platform allows Simon to track all of this Internet of Things data in real time, he can be confident that the production equipment, tools, and employees will be able to safely take on an accelerated schedule and make plans to move forward. Once the completed aircraft from Simon's plant is put to use, those manufactured parts continue to generate data over time, data that designers and engineers can use to make improvements and updates to each part in the future. Additional sensors also make it possible for Simon's plant to offer cognitive solutions to the airline to help with ongoing predictive maintenance of each manufactured part. Using the power of the Internet of Things paired with cognitive computing and analytics, companies across all industries will improve the way they design and manufacture connected products. Products that will change the way we work and live.
So now what we have learned from the two videos, just the idea, especially for IoT industrial. So what are the areas this will actually focus? The manufacturing process end-to-end cycle, it will help.
Quality.
Like quality. Like a faulty device, you will get much ahead of time. So this is the benefits. So IoT and TTM is less. So delivery time will be less. So end-to-end ecosystem you can cross check. Less. So that is the thing. That means we already know that the definition, that IP address of internet connectivity and communication between the device end-to-end system, the part of things. So this is just starting. That means sky is not the limit. So by IoT is an ecosystem of connected physical objects that you can access through the internet. So if we go that what are the components of IoT? So for the based on a couple of videos, so we see that it is a combination of sensors, connectivity is a main key thing, and another is people and process. So sensors is a very crucial thing. Can we go through this video to understand? We've seen different types of sensors.
So I have one question.
Okay.
So right now, how many type of sensors available for the IoT device?
Already we have mentioned the different types of
Different, different quantity. You're showing the top 15 sensors.
top 15,
Top
but
15
many
are supporting
different
sensors.
supporting. It kind of depends on different industries. Like you see that temperature sensor, pressure sensor, proximity sensors. So different types of. It depends on the use case. So the next is connectivity is the very crucial thing. That means we know that different connectivity like Bluetooth, Wi-Fi, then NB-IoT in cellular point of view, like narrowband IoT. So these are basically the connectivity terms, because we in the mobile telecom industry, when we talk about IoT, we are familiar one usual terms. What is it? NB-IoT. So another is LoRa. That means it depends on the connectivity of things. So you can say that what are the connectivity is this, and also on the depending on the use case, the LAN, MAN, WAN. You are familiar with this. So these are the things that based on the use cases. So you can use it. What are the connectivity? For example, some of the cases NB-IoT is more suitable. Some of the cases Wi-Fi might be suitable use case depending on the use case. Or we are talking about like 5G or these things. That means infrastructure level projects that might be good for these cases. So depending on the use cases, the connectivity is a key factor, and also cost-wise. So can we go for the next slide? So people and process. So this is important. That means connectivity. Well, one of the components is sensor. Then is the connectivity. Then people and process needs to be involved. Otherwise. So why this is involved? That these network inputs can be combined in bi-directional system. That means you give some input and you get some output. So that integrate data, people, process, and then better decision making. Like what we have seen for the IoT picture. The SAM's factory, they actually in the production system they get the information that these are the things, and some components of the machinery is getting faulty. So they get some decision making process is healthy.
And also, I have a good question.
Yes.
Let's say for connectivity, in what cases LoRa would be preferred over NB-IoT or vice versa?
Yeah, that understand. Like NB-IoT is actually cellular term, like one industry. If you the SIM based, but LoRa is basically important for the if you are not considered unlicensed, in that case LoRa might be suitable. Because a lot of deployments currently in the world market is based on LoRa. Okay, LoRa protocol.
So the technology behind the NB-IoT is cellular technology.
Cellular technology. Yes.
What about LoRa? Because I am not aware of.
It is a non-3GPP, that means not unlicensed, that means not cellular based. That means, for example, one of the group of company you want to deploy some IoT solution, but in the cellular network, NB-IoT is not available. So LoRa based equipment, because equipment supports both LoRa based and also NB-IoT based. So when you select the components, then definitely cost wise you have some limiting budget. So budget wise and also area wise, the distance wise of use cases, LoRa is proven elsewhere in the other market.
IP based.
What kind of
LoRa is
It is a
based
non-3GPP based. Non-3GPP. In
it's
simple
Wi-Fi
term,
based or something?
Wi-Fi connectivity can be used, but you have to you cannot use NB-IoT. That means cellular wise. That means you have to use for the specific.
The radio. More from
Radio.
the readiness point of view, is there any LoRa network provider in some of the advanced countries where I?
Yeah, a lot of LoRa. They are already available, and already some projects already implemented with LoRa. NB-IoT they are using, like Vietnam and other markets. LoRa is advanced country even LoRa is already. If you can search in the internet, you can get lots
I
of.
think the value proposition between LoRa is
Lot of comparison you can also.
and NB-IoT can be like NB-IoT is giving you high bandwidth,
High bandwidth,
low latency.
low latency.
LoRa gives you low power.
Low power. So
Long
that
range.
comparison,
Long range.
we can
and
go somewhere.
Low bandwidth.
I think this is a good picture.
LoRa is for IP based.
This is
Couple
Kamol,
PAN. Personal area network.
Kamol,
Wide
this,
area personal area network.
this might be the comparison you can get, like what are the existing technologies used, okay, and can you go to the next slide? Yes, this might be a good idea. Cost wise, data and power consumption, okay. LoRa is basically unlicensed LP1 technology. That means, and license wise or 3GPP wise, NB-IoT or CAT-M, LTM,
LPWAN is low power wide area network. So this is power division.
power efficiency.
So the example of waste management that was using the LoRa.
LoRa. Waste management is using
Now here both are LP1.
both are
License-
LP1, but one is licensed and another is unlicensed. That is why I mentioned like non-3GPP based.
So non-licensed means those will be running on top of 4G, 5G network, or it's a different type of how the access part is
Spectrum.
access network, how it is designed.
So it is like something from seeing the picture itself, I could say that the cellular connectivity requires a communication service provider to be in place. But for other networks, you can build your own, correct?
Yes.
And the deployment variations can be there. Say for example, LPWAN has 3 standards or 3 providers. So it's like MIOTY, and LoRa and
LoRa,
Sigfox.
Sigfox,
Both are-
especially Sigfox and LoRa. These are famous
Yeah.
right now for the implementation.
So these are like non-standard.
non-standard, right?
Typically standard means
Because
like a specification.
depending on the use cases, the network cellular are not ready up to that much. So that way these are developed. But these are some lot of projects have been built on this. And if you see the IoT protocols, so protocol is important because how they understand communication, like MQTT, then QAP. So these are the some protocols of IoT. So actually, this session is basically our objective is to for what is IoT high level, because it's only a 2-hour workshop. So give high level idea what is the business benefit we are getting. So as people are talking about IoT, what benefits actually companies are looking for IoT, implementing IoT or business model IoT, because companies are doing business, right? So I think the next slides we can get some idea, like common architecture of IoT infrastructure, like gateway, physical world, sensor, IoT appliance, wide area, gateway, and finally application. And depending on the application, smart grid, smart building, smart healthcare, smart supply chain, all will be built. So this is a high level architecture.
So the 5G story that
I will
solution providers actually brags about, it is like IoT to have or enable IoT, you need NB-IoT and this sort of things.
basically
Not actually 200%.
Yeah, because 5G, lot of discussion ongoing, and 5G the main thing is infrastructure, not consumer level. Consumer level 3G, 4G is sufficient. And can we just, these are the things why IoT, like dynamic control of industry and daily life, resource utilization ratio, human society physical system, access technical integrator, and universal internet network. Can we go for the couple of these videos, very, very important videos? Okay, hi, Ms. Noor.
The first one.
First, this is a 2019 Smart City Conference. Just watch 2 minutes video.
I think the conference is excellent. We see a lot of progress being made in the minds of thought leaders, the practitioners that are here from one conference to another, from 1 year to another. We have moved or are moving from a situation where we have found out what we don't want and where we fail to how we actually build things that we do want and that will be actually sustainable. And that's very promising. That's the general message that I get out of this conference.
For me, it's been so far a great opportunity to meet many different stakeholders that are engaged in making better cities for the future. As an SME, as the CEO of an SME, for me it's very important to be able to reach out to smaller and bigger players, to private and public organizations. And this is what so far the Connected Smart Cities Conference has offered to us. I think it's very inspiring. There's a lot of different people with different backgrounds, and I think engaging citizens is first of all engaging the technologists and the providers of smart services. So I think this is the ideal place to be for companies like Martel.
I think this really has become the reference in terms of gathering smart cities and communities in Europe. So I think it's very important to be here. You meet a lot of colleagues from the Commission from across Europe. So it's really like a crossroads of cities and mayors and civil servants working on these issues.
Agriculture and why we think
Because smart agriculture is one of the IoT use cases. They are highlighted in 2019 research out in
He said that Earth is so kind, it just with a pupil, with a hoe, she loves with a harvest. And I think that was true for many, many years. And we were able to feed the world quite some time. But is it still true? if you look at some countries, for example like Australia, they wouldn't subscribe to that as of today. We're also facing the issue that we won't subscribe it in some other places in the world either. So we know that we need 60% more food by 2050. But the reason for that are multiple. It's not only growing population, it's also the decline of our
Very key message. 60% food
We also get more
will be
regulation.
by 2050. How it is possible? With the existing.
With a lot of supply chain losses, another element that we can get better efficiency. And food safety is also major thing. And we believe there are new tools now available for the planet. With Internet of Things, we have machine learning.
I provided a what? What is German? German figure?
The economy, the food production.
So this is 2022.
It's not only population growing, it's also actually the rise of middle class in many of these strong growing countries, and the average calories people.
Who can give answer which country agriculture is number one?
We also have to provide substantial calories. Also the diet changes if people move from middle class and upper class.
Vietnam.
We see that the different diet has a strong impact
Spain, Switzerland.
from our eating behavior.
Brazil,
India,
no,
we will have another
Israel.
Number one based on
They don't have any land. Land versus production.
On demand side,
You can check.
Tricky question.
of data. What is happening?
Okay, you can do some skip idea.
Devices disconnected from IoT.
Now we can go for the next.
So what's the message here, Nasir? Just you can give the message.
Okay, the message here it is that we need the demand. That means by 2050 agriculture point of view. So the message is, so you have to, how can you increase your demand is almost double, but how can you increase the efficiency? So IoT or IoT, smart agriculture will help implementing, help to
Meet the target.
yeah, to record. Okay, this is very important. What we have discussed that in 2003, what from this graph, what is the picture actually we can get? And this is very important for your upcoming quiz also. And you're giving some hint. Okay. In the world population in 2003, 6.3 billion. Connected device how much? 500 million.
No female.
And connected devices per person is 0.08. That means 2003. Now it is 2019. So next 5 years, next 7 years, 2010. So what is the world population? 6.8 billion, right? So what is the connected device? Can you get any picture, correlate anything?
12 billion.
Connected device is 12.5 billion. Connected device.
Per person,
So-
two connected.
So more people connected device is greater than more human. So this is actually this year 2007 or 8 when the IoT term just started. But 2010 your ratio is 1.84. So after 5 years, that means 2015. So what is the world population? 7.2 billion. And what is the connected device? 2 times 25 billion. So what is the ratio? 3.47. So what is your forecast for the 2020? 7.6 billion. What is another good question? So what is the Earth's capacity for human perspective? Any idea?
Capacity.
10 million.
Huh?
Mumbai, what is the capacity of Earth?
Earth. Any idea?
Capacity you should know.
10 billion is the capacity.
Only
10
10
billion. 10 billion.
What are the losses? Equally distributed. Equally distribution of land.
Capacity will be over by next 10 years.
How can we then scale up, Nasir bhai?
Huh?
next capacity
So
expansion.
that is why this is called some
People
digital
are
disruption.
in moon and They have in to Mars.
uh,
Scale down. Nuclear
So,
weapons.
otherwise, I have read one report from Bangladesh.
Okay.
After 15 years, Bangladesh people will be less from the current population.
How it will go underwater?
Yeah, it will be
Underwater
because
people will-
now the people are very careful about their birth plan. So people, the quantity of people will be very
Death rate will be more than.
so they have to be very low.
Yeah.
People will move up to Now Canada. mortality rates has also increased Australia. Not from childbirth or child point of view, but from grown-up kids. And more actually aged people are dying in because of
Okay,
dengue and all this.
okay. Our time, we can discuss more later on. But as our time is running out, we have to complete all the slides. Okay. So 50 billion is the target for 2020. 20. That means we started the graph 2003 and 2020. That means within only 17 years, the ratio, if you consider ratio, how much?
Connected means connected to the internet.
Connected to the internet, yes.
20 devices per person, so like 7 gadgets per person.
7 gadget, what do you say? No. Like, for example, your
Sensors, right?
sensor based. Like your
Okay.
fridge,
No,
your
no.
TV.
Nothing is connected.
In-
No,
in-
not
in-
connected.
in-
These are not
Fitbit
connected
or
sensors.
something.
May not be internet, maybe local network. If
says
it can connect,
it says somehow connected.
and if it can connect to a network. any
Connected.
network.
Then it's okay. My phone is like my phone is actually down. Your
So
Freeze.
this
Freeze down.
idea we can.
But you have iPhone, then
So this is the growth in the
Earbuds.
Fitbit,
revenue point of view. Can you go to the next slide?
devices.
This is the GSM data. What will be the revenue by opportunity by 2025 according to GSM? And also the region wise also. You can get the Asia Pacific is a high growing region. Revenue opportunity. 386 billion. Middle East,
It is
medium.
based on population or the use case?
No, based on use cases, the demand. So these are the $1.1 trillion opportunity by 2025 according to GSM. According to GSM,
What is the forecast for Bangladesh?
Huh? No, they focus region wise. Like what are the things like 1 billion connected industry will be connected, then connected vehicles and consumer electronics, smart home. So a smart home is a very good use case for this. So this is the IoT evolution. That means if we consider like pre-1990, 2010 up to now. So what the phases IoT we can go like pre-1990, the ARPANET is introduced and WW is introduced in 1989. And if we go to the 1990 to 2000 region, we see that in 1990 internet devices such as internet operator poster and webcam was developed. And in 1991, the first web page is created. Remember it might become in the quiz. Invention of Wi-Fi technology. So these are the periods.
IoT term was not.
In 1998, Google is incorporated. IoT was coined by Kevin Ashton, the founder of Auto ID Labs. LG Corporation, South Korea, they announced the first internet refrigerator during this period. And this data is coming from University of Colorado. So it is not a fake research, authentic information. And 2000 to 2010, we see that some project like Cooltown, Internet Zero, RFID. So RFID came into the picture during this period. In 2005, the UN published the article on the IoT. And if we go to the 2005 period, first report of IoT published by ITU 2006, European IoT conference was conducted. And China announced major investment in research related to IoT. During that period, that means we are talking about the competitor, Huawei. So already China is well aware of this, to capture the business and everything.
What about the Ericsson strategy for this IoT?
IoT, Ericsson, I see that they came very late, but
Ericsson is mentioned.
But Nasser bhai is here now to take the mental
but
forward.
yes,
Yes, the
I think that
research
now they
mentioned
in
Ericsson.
2010 actually they after 2010 they
Using 10 till present.
5G is all about IoT, right?
Yes.
So Ericsson is in the game.
Yes. Hopefully that Ericsson can turn the game out. That's it.
That's the speed.
So these are the four phases of industrial internet. We can term like short term and long term. So Mahfouz, where are you?
Trick question for it. Trick question.
It is out of connectivity right
Okay.
Not in the connected world.
Offline.
Okay, so short term is the main two thing, operational efficiency is the main objective, and new product services. And long term is outcome of economy and full economy by end-to-end automation. This is very important. Like we see some statistics here. So what are the business benefit? We are talking about IoT. So what is the business benefit we are getting from IoT? Why we want to adopt the industrial internet? So what from the data, can you say which is the key factor? Optimize asset utilization, reduce operational cost, one of the major objective, improve worker efficiency, productivity, enhance worker safety, that's not much, but create new revenue stream through new products and services. This is everybody's objective, the company's objective. And improve sustainability and enhance customer experience.
What is the meaning of this color and percentage?
Right. Here it is, if you see that yellow mark, this is very extremely important. So, important point of view, this is the revenue opportunity from IoT is the main business benefit. Next. So this is the revenue opportunity from one of the data. What is the growth we are expecting from adopting IoT by 2022? This is 2019. If you see that the initially term like 2014, 93.7. If you consider like we are 2019, 364 US billion, 20, and that means the IoT e-journey is right now started. This is 2019. So 2020 it will be 491 billion. That means today we are expecting 364. Next year our target is around 500. And then next year is around 700, 2021. And then in 2022, it will be like 883, almost near to 1 trillion. So summary is here. In 2015, it was 130.33 billion and expected to grow at 32.4% between 2016 to 2022. What is the main growth? That internet connectivity, wireless sensors, and mainstream of cloud computing. So these are the key factors. So why IoT is connectivity. And what transportation, building automation, industry. So these are the top application of IoT technology market. So that's why our CEO even says that connected industry is one of the major business area. So this is actually the GSM survey, like policy regulation wise, what are the things like what we discussed, industrial IoT, smart cities, smart agriculture, drones. Smart agriculture we see from that Bosch presentation. So this is the value chain. This is one of the very key things. Like when we see IoT, there are a number of players. What are the players? Can you get any idea? So to it.
Google players.
Google players.
No, Facebook is not an
IBM,
Accenture.
all of them are IT software customization.
So I can see real root there.
The software like IoT accelerator. Ericsson is talking about the IoT accelerator. So application wise like Salesforce, these are the key things. And platform wise Cisco, Microsoft, Google, IBM. And connectivity. What is the key role of GP, Robi? Connectivity. So these are that means sensor players. So they are also one of the key players. So each player has his own market share. IT value chain. That means if you see like 15%, if your business is 100%, you can segregate. So you can distribute like 10%, 15%, 25%. So these all players have the opportunity for to grab the IoT revenue. Next. So this is the approved IoT use case according to BTRC. Smart smart city, smart building, smart grids, telecare, industry automation, water management, smart agriculture, environment management, smart urban lighting, waste management, smart parking. So these are the key approved IoT use case in Bangladesh according to BTRC.
This is important. This is important.
Very important.
So, okay.
That's why government objective is smart city, how these use cases can help. So after IoT, we'll go on board to Udhay and Irani.